So I made a little bit of a mistake. I just realized at the end of the other video, we had just finished talking about this part. And this matrix multiplication that I outlined here, it does capture all of these constraints, but then I totally forgot that there are n more constraints. There are also the constraints that say that zeta I has to be greater than or equal to 0 for all of the zeta I. So we need to modify this in order to include those constraints. So how can we update this matrix to make that happen? I'm just going to change this little bracket here. So this is going to be n. So we'll keep going. We'll do one of these for every data point. And so let me put in just a dot, dot, dot here. So we'll eventually run out of data, and then we'll have x0, n, y, n, x1, n, dot, 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 and then we'll have, oh, sorry, I need a little bit more space. And here we'll have y, n, x, d, n, and then we have the part of the identity matrix that we're building over here. And so the very last one will be 0, 0, dot, 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 0, comma 1. All right, so that'll be the last row of the identity matrix. So what have we got over here on the right? We've got this n by n. See how this is n, and this is n. So over here in this part of the matrix, we'll basically just have the n by n identity matrix. And here we'll basically just have all of the data. Okay, and now let's start thinking about this last series of requirements that we want here. So here I had said that v was d plus 1 plus n ones. I realize now that's not going to work. What we actually want, so when we get the things here, all of these that I just outlined, we want to be comparing these to 1. So that we can capture this constraint right here. So we do want those to be 1s. And then let's just put a last 1 here. And now let's just kind of think of this as being like the end of that. So this is n 1s here. Okay, and what we're building is this v. So here's v, okay. And now we want the rest of these to be zeros, because now we're going to start working on this constraint, which is the constraint that all of the slack variables have to be positive. So I need 0, 0, dot, 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 0. And how many of those do we need? That's right, we need n of those as well. So we actually need n more rows here to address all of that. And so how are we going to pick out these slack variables when we do this matrix multiplication? So we don't care at all about the w's. So we're going to have, d plus 1 zeros here in every row. And that's going to basically nullify all that. And now we do care, at first we care about like this first guy. So we'll put a 1 there, and then zeros everywhere else. 0. Okay, so there's going to be n of these. And now what's going to happen is this is basically going to be the identity matrix again. So see how that's going to work, because in the next row, we're going to focus on this guy, and we're going to zero out everything else. So this will be all zeros again, 0, 0, 0, 0, 0, d plus 1 zeros, and then a 0, and then a 1, and then the rest zeros. Okay, so let's see if we can just sort of like revisit A here in kind of block form. So it seems natural to break it into, there's going to be n rows that are basically dealing with those first constraints, n rows dealing with the second constraints. And let's break it up in block form here. There's going to be d plus 1 entries here, 1 for each weight vector. There's going to be n entries here. Okay, so we have this n by n part. And what that is basically going to be is the identity matrix, which is n by n. And then here, this is actually going to be exactly the same thing. Another copy of the identity matrix, which is n by n. Okay, and now what have we got here? We've got just all zeros. The n by, no, sorry, d plus, I was right the first time. It's n times d plus 1 zeros. There's n times d plus 1 zeros. And now what have we got over here? This one is basically kind of like y broadcast multiplication times x. So what I mean here, I'm going to write a little asterisk there. So what I mean by that is just like the respective product of the rows of y with the rows of x. So x is n by d plus 1, and then y is n by 1, and you're just going to multiply all the y's into the respective rows of x. And that's basically what a is going to be, and then we have, we're going to multiply that times z, and then this is going to be greater than or equal to this vector v, and what is v going to be? V is going to be n ones, and it's going to be n zeros. Okay, and that should do it. So that is, now you just have to turn that into the code for the quad prog.